Good morning, friends. Today we are to continue the next part of this unit. The question is that how are the primary, secondary, and tertiary alcohol distinguished by oxidation? Oxidation is nothing but the addition of the oxygen. Oxidation of alcohols gives the aldehyde, ketones, or you can call it oxidation is nothing but the loss of the hydrogen also. Okay. Then oxidation of the alcohol gives an aldehyde, ketones, or carboxylic acids. The nature of the oxidation product depends on whether the alcohol is primary, secondary, and tertiary. If the primary alcohol on oxidation first gives an aldehyde, which readily oxidizes to give the carboxylic acid containing the same number of carbon atom. Example is you can see the ethanol. If you take the ethanol and you do the oxidation by using the K2Cr2O7 in presence of the acidic medium, it will provide the nascent oxygen, and that nascent oxygen will try to add up on the carbon. Meanwhile, there will be the loss of the water. From this particular H2O will loss, and at the position of this particular carbon, double bond O will be there. And this whatever the aldehyde, that is acetaldehyde, will form, and that acetaldehyde when react with the one more nascent oxygen, it will get converts and it will gives you the formation of the acetic acid, means CH3 C double bond OOH. Got this point? What is there? What we have seen basically in that whatever primary alcohol will gives you the acetaldehyde, okay, and which on further hydrolysis gives you the acid. Whereas the secondary alcohol will gives you the ketone containing the same number of carbon atom, which on further oxidation form the carboxylic acid containing the lesser number of carbon atom. You got this point? Lesser number of the carbon atom. What is their basic difference that you should remember? What we have seen? See, here example is given, that is isopropyl alcohol, or say you can call it as a secondary propyl alcohol. In case of the isopropyl alcohol, you can see there, easily you can identify what is there. We are taking again that K2Cl2O7 H2SO4, K2Cl2O7 in acidic medium, that's why the H2SO4 is there, which provide the nascent oxygen, and that will add up across the carbon. It will give the formation of the acetone CH3 C double bond O CH, that is a ketone, plus H2. This acetone will again react with this the nascent oxygen coming from this particular K2Cl2O7, which will be the vigorous oxidation. It is called as a vigorous oxidation. Why it is called as a vigorous oxidation? Because in this case you will get a formation of the acid, okay, along with there is some byproduct water, and the removal of the carbon dioxide will be there. Okay, there will be the removal of the carbon dioxide will be there. Then next part is that tertiary alcohol. Means you have to distinguish between the tertiary alcohol, secondary alcohol, and the primary alcohol. For this purpose, this reaction we have to use. Unusually, on using not you have to make correction, and using a very strong oxidizing agent such as the acidic potassium permanganate, etc., the tertiary alcohol get oxidized to the mixture of ketone and acid, each containing each containing the lesser carbon atom than the original carbon atom. Means you can see here, first of all KMnO4 you take, which will give the formation of the alkene. Then we can carry it out the vigorous oxidation by using the K2Cr2O7 in presence of the H2SO4. It will give you the formation of the dimethyl ketone or say ketone or say acetone. And which on further oxidation it will give you the formation of the what will give acid. You can write this reaction, you can complete this reaction, but you should have to remember this, how we can differentiate between this particular acid, that primary alcohol, secondary alcohol and the tertiary alcohol. Primary alcohol, that will gives you the just formation of the aldehyde. After the further hydrolysis they will give the acid with the same number of carbon atom. When secondary alcohol reacts with this particular on oxidation, they will give you the ketone, and further they will give the acid with the less number of the carbon atom to the original one. Okay, then next we have seen the tertiary alcohol. Tertiary alcohol when oxidized, first of all we have to use the that strong oxidizing agent like the KMnO4, acidic KMnO4, there is a potassium permanganate, and it will gives you the formation of the first of all alkene, and that alkene on the further vigorous oxidation it will gives you the that ketone, and ketone will further gives you the carboxylic acid. Okay, that you have to see. Then what give the reason? Ethyl alcohol has the higher boiling point than the ether, even though their molecular weight are same. Lower alcohols are soluble in water, and third alcohols are extremely weak acids. Effect on boiling point, first of all first point will be there. Ethanol form intramolecular hydrogen bond. Hydrogen bond formation result in the association of the alcohol molecule. Therefore, more energy in the form of the heat is required to break this particular hydrogen bond holding the molecule together. Therefore, alcohols have the higher boiling point. Second, an alcohol molecule is capable of forming hydrogen bond. It can be split into hydrogen bonded sequence in water. It can replace the hydrogen bond that must be broken to let them in. Thus, alcohol have low molecular weight, are soluble in water. Then about the acidity of alcohol. Alcohols are extremely weak acid due to electronegativity of the oxygen atom. However, this is opposed by electron repelling, means negative eye effect of the alkyl group. Hence, alcohols are extremely weak acid. Okay, why these alcohols are? Three questions are there. For these three questions, we have seen the answers. First one was the why the ethyl alcohol has the higher boiling point than the ether, even though their molecular weight are same. That was the first question. Okay, then second question is the lower alcohols are soluble in water, whereas lower molecular weight alcohols are soluble in water. Okay, then alcohols are extremely weak acid. These three questions are there. For these three particular questions we have seen the answers. First question is that we have seen ethyl alcohol has higher boiling point because of hydrogen bonding is there, and due to this hydrogen bonding the association of alcohol molecule is there. It requires a more energy in the form of heat to break this particular hydrogen bond. Therefore, alcohols have the higher boiling points. And the second question about their solubility, alcohol molecules is capable of forming the hydrogen bonding. It can be split into the hydrogen bonded sequence in water. It can be replace the hydrogen bond that must be broken to let them in. Thus, alcohol of low molecular weight are soluble in water. And about the acidity of these particular alcohols are extremely weak acid because of same electron negativity of the oxygen atom. However, this is opposed by the electron repelling, that is a negative effect of the alkyl group. Hence, alcohols are extremely weak acids. Okay, these are the few questions which are based on this particular alcohols that we have to the sometime that come in the exam. Why these alcohols are the weak acids, lower molecular weight alcohols are soluble in water, and why the alcohols have the higher boiling point than the ester, though their molecular weight is same. That questions you have to prepare well. If you are not getting, you can ask me again. And today we will stop here. Thank you.